Hi, this is Roger from Kankan Labs, and today it's about how to discern true germanium diodes from fake germanium diodes. We encountered this problem when we wanted to take some germanium diodes for our Crysta-Radio set into our shop. We ordered some, and I had from the first moment on the suspicion that the crystal diodes that we got, which were of type 1N60P and type 1N34A, as you can see here, that they were not true germanium diodes, but in fact Schottky-Diodes. We won't discuss here if germanium or Schottky-Diodes are better in a Crysta-Radio set, but just how you can make a difference, how you can discern the two ones. So here I've put a true germanium diode, which you usually can recognize by its glass body, its transparent glass body, where you can see the semiconductor junction. Not very good here in the video, because transparent glass is not very good to see. You can see the green ring here. By the way, it's an AA118 germanium diode, and this is 100% sure a germanium diode. And I've put it into our universal super Crysta-Radio set, already available in our shop, but I didn't make a video about it because the English translation of the manual is not yet ready. Anyway, here we have the possibility to put a very low and variable bias current and bias voltage to the rectifier diode. And it's very difficult to find out if you have a germanium or Schottky diode if you measure the forward voltage and the forward current, but it's very easy if you measure the reverse current. So we will put in, as you can see, I've put a multimeter in millivolts mode and a multimeter in microamps current mode, just to measure the reverse voltage and the reverse current. And now let's put in the true germanium diode, and we'll crank up the reverse voltage. And you can see already here at only a little bit above 1 millivolt, we have already 70 nanoamps reverse current. And let's find the point where we get 1 microamps reverse current. That's around here. So at 40 millivolts, we already have 1 microamp reverse current. And that's very typical of germanium diodes. Even this one is even a more modern one. The first germanium diodes in Europe had the letters OA in front of the number. The more modern ones have AA in front of their numbering. And germanium diodes are notorious for having quite large reverse current. And you can see this here, 40 millivolts reverse voltage and already 1 microamps. And now let's put in, for comparison, what I now know is a fake germanium diode. First of all, the 1N60P. And, oops, the microamps meter has turned off. So, here we, even with more than 1 volt, let's put it to here at 600 millivolts, we are still in the nanoamps region. So this cannot be a germanium diode. This has nothing to do with modern doping, that modern germanium diodes would have less reverse current. It's an inherent feature of germanium diodes. They always have high reverse current. And here at 600 millivolts reverse voltage, having nearly 0 reverse current is a sign that these are in fact Schottky-diodes. And you already can see they look very different. They look like typical Schottky-diodes. They have this kind of orange inside the black ring, and the inside looks a bit like orange-brown. And let's compare still the 1N34A in reverse mode, and we get the same result. We can crank up the reverse voltage and we don't get in the microamps region. So you see, these are fake germanium diodes. They are sold at eBay as germanium diodes, but if you download the different data sheets, you will see some manufacturer already designates them as Schottky diodes because they have nearly the same forward characteristic, but they are not germanium diodes. They are replacements, and they are in fact Schottky diodes. So they are fake, and we put them out of our shop because we don't want to sell something that is sold to us as germanium diodes, but which in the end is a cheap Schottky diode made out of silicon instead of germanium as the semiconductor. So that was it for a short finding we had here at Kanka Labs, and I hope you liked it, and stay tuned for the forthcoming video series about our advanced universal super crystal radio set. Until next time, bye from Roger, bye from Kanka Labs.